Okay. I don't think I hit Control-Alt-Delete. That would have given me a warning, huh? That's going to puzzle me. All right. I'll have to ask them. Restore. All right. So we were talking about the Boolean and the sign and our stuff here. And the other site I want to show you is, if I go back on this one, let's try that again. This one here, all about circuits, it does the same thing. It takes a circuit and then it shows you how to write the Boolean expression and then how to reduce it, okay? So this one is giving you the understanding of what's going on, okay? So these few sites that I have given you from my links here, these things, right here, these ones. As you move on into your computer science upper grad, this stuff is going to save you a ton of study time, okay? And your instructors may show you this, but your instructors will want you to break down the Boolean and so on and so forth, especially if you're into engineering. You got to know how to do it, okay? It's kind of like, all right, everybody, grab a piece of paper. I'm going to do this anyway. Who's got paper? Nobody? Oh, well, let's pass some paper around. We're going to do this just for fun. Let me get everybody's attention. Okay? Grab some paper. And if you need pencils, I have pencils. You can rent them for $5. Okay? So so let me know if you need pencil or paper. We're going to have 2 seconds of fun. Okay? All right. And start with, put your name on top on the paper. And yes, this is a quiz. And how many points is it worth? I don't know, 10,000, 500, 3. I don't know. It depends on how well you do. If you all do well, it'll be worth something. If you all do terrible, then it'll be worth nothing. Okay? We're going to have fun. Okay? Everybody set with pencil and paper for the most part? Here's the quiz. In the programming language of your choice, no computer, no phone, write a for loop that counts 1 to 10 on a blank piece of paper. I don't care what language it is. Just write a for loop that counts from 1 to 10. And we'll give you 2 or 3 minutes. Be sure to put your name on it. If you can't think of the syntax of an actual language, do the best you can with pseudocode. Pardon? Pardon? Oh, no, it just prints 1 to 10. It doesn't have to print to, just print to the screen. Like whatever your language uses to get it to the screen. I'll give you lots of extra points if you write this in assembler. And if you're drawing a complete blank, don't feel bad. I've done this particular quiz many times, and I'm always a little disappointed, but then again, I'm going, why should I be? Everybody's wired to their phone 24/7. All right, turn them in. If you're not done, you're not done. All right, let's talk about this for a second. We're going to do a for loop that prints 1 to 10. So we need the for syntax, whatever that is, for your language of choice. And then we need a counter. So we need to set up a counter. And then we increment the counter. And then we print the result in the middle during the loop, and then we end the loop. Okay, that's it. Okay, it's okay to memorize a few things like this. For, if, case, or depending on your language, else if. Okay, so let's go ahead and pass them over, pass them forward. And I'm using this as an example of what you need to know in the world versus what you don't need to know. Okay? Do you think as a job, as a programmer, you should be able to do this? I would say pretty much hand down. There is a wonderful book I will bring in next week. It's called Cracking the Coding Interview, about yay thick. It's got a pretty deep history. And it's all questions that you'll get from Google, Facebook, Amazon, saying, here's an example. Now, what I just gave you an example of, it would show up in an interview. For example, there's one on the web that I read about. I thought it was really interesting. And these are HR people that work with senior software developers. And they're saying, write a for loop that goes from 1 to 100. And if it's divisible by 5, print fizz. If it's divisible by 25, write fuzz. Write it on the whiteboard. Go. That's an interview question. You can't pass it. You don't get the job. So it's okay to have some mastery at that memory level thing. It's not a skill we practice very often, because where do you go when you need something? You go Google it. Information at your fingertips. The whole idea, you can look up anything you need for all your problems. Now, if you go online and find, I want to write a for loop in Python, you'll look at it and go, oh yeah, I know how to do that. Oh yeah, I remember now. But that's not the point. The point is you need to remember it before you look it up, okay? So that's kind of it's a fun little exercise. And no, I'm not going to grade it, okay? I'm just doing it for your edification, to help you realize, as you come into school, you're probably in computer science because you're interested in gaming and everybody in your family calls you for tech support. Therefore, you think you know something. That's okay. There's a whole lot more to learn, okay? Which is why we're all here, okay? Because I'm learning from you folks all the time, okay? There's no way I can know all this stuff, okay? So on that note, should we write a for loop? in our language of choice. All right, let's use the Jupyter Notebook. Everybody hop on because I want to test it, see if it all works. Yeah. Yeah. Did you try it at midnight? It worked. At 10 o'clock, it didn't. I got it working about 11 o'clock last night, and I gave a quick example of why it worked. Okay, now what I want you to do is when you first log in, let's go to Notebooks, and then I will just bring this up so you can see it. It's nice and simple. And I'll say, and in this case, I just want to print Y. Oh, ancient history. Ancient history. You use the first part of your email address, which is your first name and the 6 digits. And then the first password, we went in and changed passwords. I believe it was Linux, lowercase o there, X231 was the first password. And if you've changed your password, I don't know what it is. So we can just trash it and give you another one, okay? Let you change it, okay? So this is a for loop in Python, okay? Now I said print from 1 to 10. Did this print from 1 to 10? No. How many different ways to make this correct are there? Yeah, several, okay? There's none of them that are wrong. This is an easy one. You just add 1, or you can actually use part of the range statement and have it start at 1 and go to 11. That also works, okay? Either one of those will work. So, and I didn't say anything about carriage returns or line feeds, just write a simple for loop. Now, in Bash, it looks different. In C++, it looks different. Java, it looks different, okay? But the concept's the same. Set it up. Now, in C and C++, I have to take a Y and turn it into an it, right? Why are we doing this? Because we're going to take our for loop and we're going to turn it into assembler. And we're going to do that today, okay? And I'm going to show you what the output of assembler looks like on both the Raspberry Pi and the Jupyter Notebook, okay? So we're going to have to dust off some skills in the brain, okay? I can write a for loop in Bash and in Python, C++, maybe, if I play with it a bit. But C, which is the target language we're going to be using today, maybe. We'll have to see, okay? So let's start with, I don't think you have these in your, you don't have them in your, let's go there, okay. Do you have a directory called C++ in your notebook? Okay, go to that one and let's go, which, is there a hello in there? Okay, let's look at the hello. All right, this just simply enters your name, okay? And this is how our compile string works. So let's take this working code and learn how to compile it using the terminal, okay? So we're going to learn how to navigate the command line a little bit using the compiler suite. Now, if you're in the world of Visual Studio and Eclipse, IDE, all that stuff's magically done behind the scenes, which is great. But what if you need to change a parameter? How do you do that? Well, what parameter do I need to change? So understanding how it works at the command line and what your parameters are at the command line is going to help you figure out your problem with Visual Studio, okay? Which is why we start this way, as Chris calls it, no handlebars approach to coding, okay? There's no safety. We make all kinds of mistakes. So this is working code, okay? So what I want to do is I'm simply going to put this into my paste buffer, and I want to open a terminal. Now, how do I open a terminal? Well, I go to where I see my directories and say new terminal, okay? Now, using that piece of paper that you have handy, here's a few commands that you're going to need to know to get around in the command line, okay? And I will give you both the commands for DOS and Linux, and what works on Linux works on Mac most of the time, not always, okay? All right, we're all familiar with the directory tree when we bring up Windows Explorer, right? I have a tree, and here's my files, right? We're all familiar with that a little bit. Do you know how to get around when you're here? Same principles, okay? We're doing the same thing, okay? So if I want to put something on my desktop, I have to move into a folder to my desktop and create the file, and I put it on my desktop, okay? I demoed that really fast a couple weeks ago, maybe a day ago, I don't remember, but I know I demoed it. All right, so now that I've opened the terminal, now everybody try to follow along with me here, okay? Now, if you're on a notebook, are you also on the Jupyter Notebook? Awesome, good. I had one semester, but that didn't work, okay? All right, so we're good. Now, where am I in my file folder structure? I'm in my home directory. And where is that? I can find it by saying PWD, which means print working directory, okay? And in DOS, it's called the same thing, I think. Or is it CWD? Nope, CWD. Nope. What is it? What is it in Windows? Anybody know? CD? Yeah, it's just CD. You change directory, but don't change the directory and just type in CD and hit enter, and it tells you what your current directory is, okay? And I'm using DOS only because I don't know PowerShell that well. I'll admit it, I don't know it. Yeah, they've got the, you know, what's nice about PowerShell, they've got all these aliases built in now to make it look like, feel like Bash. It's really good. Yeah, it's still Windows. Okay, so here's our directory, but where was that file? We clicked on a folder and it was called what? CPP. So we need to change directories into CPP. Any gathering, any glimmers of what you might think? Yeah, to find out what's available, we can do ls, and this shows you what is list everything. And there's like 9,000 flags on that, okay? All right, in Windows, it's called dir, okay? It stands for links list stuff. It's short for list. Right, that's an alias. And that's done, if you just type in the word alias, you'll see all the aliases that are built in. And yes, I put a few in for you to make your life a little easier. And if you happen to forget that you're not on DOS, dir will work. So there's a few other in there. So these are the aliases. Some of them I've created, some of them are system, okay? If you want to clear your screen, just type in clear, all right? So PWD, LS. Control C. Yeah. Okay, just close the window then. Oh, you did it in the command line. Oh, okay. Well, there's a way to kill the process. What you would do is open another terminal session, and then you grep for that process. Grep is a term. You know, you're looking for something, and you can find that process and then kill that process, and then it will stop. Okay. But how you're going to do that right now, this second, I'm not going to tell you because we're doing something else. So just reboot, and that'll work too. Okay. So we need to change directory into our C++. Okay. So we simply do cd C++, and we can do ls, and there's all our files. So this hello CPP is the one we want to compile. Okay. Right. There's some shortcuts with Z shell. And the reason Mac went to Z shell from Bash is because of the licensing. It had nothing to do with tech. It was all about licensing. They could encumber Z shell. They couldn't encumber Bash. So now they can extend it the way they want it. You know, embrace and extend, right? Okay. All right. So now we want to take this file. So let's see what's in my hello.cpp. And we can use this thing called cat. Okay. Now, what I'm giving you here is stuff that you will need in those good high-paying jobs, you know, where Amazon, all that good stuff. Okay. So we talked about PWD, ls, cat, cd, alias, and a few others that I probably forgot. So now if I cat that file, looks the same, doesn't it? Okay. So this is what it's going to do. Okay. So what we are going to do now is we are going to compile this in C++, and then we're going to run it and see what it does. Okay. So our compile string works like this. We tell it what kind of compiler we're using. So for most of our term, we'll be using GCC, which is a C compiler. This is C++. So it's called G++. Okay. You can also compile using the GCC suite. It compiles Go and D and a bunch of other languages. Okay. And then we're going to say -O. When we're done, we want to compile it to an object that is executable, like a .exe on Windows. Okay. And I want all warnings. That's what wall means. Warning, all. Give me all my warnings. And then hold my C++ standard to the 2011 standard. Okay. Just because that's what we use for the most part. Most of our textbooks that we've used adhere to the older standard. The newer standards are slowly coming out of the textbooks. You know, C++ textbooks are, you know, that thick. Okay. So let's compile it. So we can type it in, or if you're lazy, you paste it in. So when I compile it, oh, nothing happened. Something did happen. Let me show you what happened. This is where we use a command called ls-ltr. List my files in a long format by time in reverse order. That means my last file is the most current, okay, which is hello. So now notice how it's green. That doesn't really mean much to you. What you really need is to know is these X's, okay? These X's say it's executable, which means it's object code, which means I can run it. So let's run it. /hello. What is my name? Ta-da! Works. Okay, everybody make theirs work. Everybody got it? Cool. Now, I compiled it. I compiled the human readable source code into object code. Now, what does that object code look like? Let's use that's what it looks like. A bunch of hexadecimal stuff that's stored on disk. Now, if I try to cat it, that's what it looks like. It's a mess. Can't edit it. Okay. It makes a royal mess. Okay. That's what actually runs on the computer. Now, let's do something a little different. Let's take that same command line. And I think I have to put it here. What did I change? Now, what did I change on this line? -S. Dash uppercase S is something different than dash lowercase s. I'll leave that as an exercise for you to read up on. But now let's do LTR. You can use Stu's up arrow and see what it is. It didn't output it, darn it. Let me try lowercase s, because this is G++. I think this one, nope. I actually have to put a name here. Let's do, no. This isn't working with C++. So we'll come back to that. So basically we compile it and it works, okay? Now, those of you that are in the Linux class, or if you're a sysadmin, or you're going to make your living at the command line, there's this editor called VI. Don't jump into this yet. VI is the editor everybody loves to hate. It's been around forever, and I've used it forever. And when Bill Joy originally wrote it, he says it needs to be rewritten. So even he admits this is not the best. But at the time, everything was constrained by memory, and VI allowed you to edit code on a terminal using a full screen. This is what it used to look like. I think it's EX. This is how you used to have to edit code. Line by line. So you had to hold the entire code in your head. Anybody want to go back to the good old days? I certainly don't. You made all kinds of mistakes. You spent a lot of time troubleshooting typos, okay? And basically, that is the line editor, is how computing was done until Bill Joy invented the VI editor, okay? So there are other editors out there. There's Joe, there's just a ton of them. There you pick as many as you want. But the reason I recommend you learn VI is on every single Unix flavored box, including a Mac, you touch, you will find VI. You may not find Nano. You may not find Joe or Emacs or Visual Studio or, but you can always find VI. Yeah, a little bit louder, please. Oh yeah, you just hit Q bang. Oh, isn't that fun? Okay. Oh yeah, Control C. You're in EX mode. Okay, so it says type visual to go into normal mode. Okay, now hit there. Okay, let's see here. Just do Control C. Okay, now hit Q bang. Yeah, bang means exclamation point. There we go. All right. Yeah, that does happen. This happens frequently. Okay. All right. All right. So as you're why are we doing this? Well, we're getting to that. Okay. Where we're going next is I'm going to have you type in some code. Oh, as far as a login? Oh, well, let's see. How many are having trouble logging in, Jeremy Box? Didn't raise their hand. I know there's more than one, yeah. Yeah, I figured. Yeah, okay. So what you need to do is that's the default password, is that one. And your login is going to be your first name and whatever your digits are. Why is that one so long? Oh, it's Mitchell, not Mitch 11. Sorry. All right, never mind. So that's the first part of your login when you log in. Okay. And then it's your password. Okay. Now, once we get you to log in, later I'll show you how to log in from the command line from your Windows box to the Jeremy box. And you can do stuff from the command line. You can do this, everything we're doing today, on your Windows machine from this lovely prompt. Okay. So not fun, but it works. Okay. All right. Lowest common denominator. So did you find your username? Okay, good. All right. Now, if you changed your password last time, all right, what's your username? Oh, Omar. Let's see how many Omars I have on here. Let's see. Only one. So is this you? That's not the right Omar? I'm you. Oh, you. Umar. There we go. That you? Okay. I'm going to change your password. Oh, I have to do this as super user. That'll be your password. Okay. There's always a way. All right. You should be able to log in. Sure. Paul. This one. This is that day where we did the password change and we forgot what the passwords were, which makes it interesting because you don't see the star when you change your password. So if you're uppercase, lowercase, you don't know that you're uppercase, lowercase. You don't know you embedded a backspace into your password, which you can do. If you want, you don't have to. It just makes it easier for you to know your stuff hasn't been messed with. Not that anybody would do that. I had some students that were actually helping me figure out a virus. You should be able to log in now, Paul. And one of them kind of had this impish strength, and he picked on everybody in the class, but there was one person in the class that just mad, so he picked on him even more. Yours? Sure. STEM. ST. Sam. Don't you love it? Working with a deaf guy? There we go. Should be able to log in now. When we were in the other building, I was talking away doing something, and there was this huge car crash outside the on whatever road is south of here, and I didn't hear it. I was talking away. Everybody in the class goes, "Didn't you hear that?" Like, I better get my hearing checked. So, all right, now back to where we were. What we're going to do now is we're actually going to create, because you don't have a folder called ASM, I don't believe. If you just type in CD, that takes you back to your home directory, and do PWD. And if you do LS, you probably do not have this. Okay. All right. So shall I torture you with more command line, or should I show you the easy way and how to use the GUI tool? Okay, command line. How about I show you both? We'll show you the GUI tool first, and then we'll do the same thing in the command line. So go back to your Jupyter Hub up here at the top, okay, where you want to be at this top level where you have notebooks and C++, okay? So you need to be here, okay? Then what you're simply going to do is type in new folder, okay? And then it will create a new folder somewhere. Maybe, I hope. Anybody else working or not working? Oh, there it is, untitled. It creates a new folder called untitled, okay? Then all you have to do is rename it. And how do you rename it? Well, you click on the little icon and you say rename. It's not the most intuitive interface, but what are you doing? Yeah, this interface is weird. You are in the web. You are on a client manipulating the operating system at a command line level. Can anybody see security problems with that? Yes. When you go to a bank website, can you get to the command line on the bank website? No. If you can, make a big withdrawal and then get out of the country, because I'll find you, okay? So just rename it to whatever you want. ASM would be great. I'm going to use ASM2, just so I have both right next to each other, okay? So now you have a directory and there's nothing in it, okay? This is what we're going to do. In ASM2, It says there's nothing there. Click on New Text File. Then I will bring up what you will have to type in. This is what you will type in, okay? All right. Now, this is C source code, not C++. And we are going to type in this code, and we're going to compile it to assembler. We're going to look at what assembler looks like as a language. That's what this line does. And then we're going to run it. That's what, or compile. We're going to compile the assembler, and then we're going to run it. And that's all that's in it. This is C. Notice the print F. It's a little different. It doesn't say print, and it doesn't say C out. So this is C, AKA 1978, okay? It's gone through many rounds of revisions and standards. So this is what we call standards-based C here, because it has the init main, it has the comments, and comments in C can be either the /* for a block of text to comment, or the // just like in C++, to comment out an individual line. Okay, so practice your typing skills. And then as you type and make a change, for example, I put in a single space here and hit enter, you will see that this little star way up high in the corner, that means it's not saved. Okay, so now if I hit save by doing File, Save, that little star goes away and you get the little box comes up, says File Saved. And it's also highlighting it for you automatically and telling you because of how you named it. So when you put .c at the end of the file, it's going to highlight it with the appropriate color for C syntax. Okay, once it's all typed in, folks, what do you suppose we're going to do next? We're going to compile it. And what are we going to do to compile? We're going to pop into the terminal, and we're going to use that command line, and then we're going to use cat to look at hello.s. And we'll take a look at our assembler. And then we'll use the GC that line 6 starts it, and then line 7 will create it. So I guess if I was going to do this correctly, I would put this in here. Just to make it more complete on the actual steps, except it should say hello. There we go. All right, so do File, Save. Now I want to go up to my terminal window, so I can just, I'll go to ASM here, because that's where mine is. I'll go to my terminal, change it to ASM. There's my stuff. Oh, darn. I forgot what the compile line was supposed to be. Cat hello.c. Oh, there it is. is, of course, sometimes I really don't like Chrome. This terminal emulator inside the Jupyter Hub leaves a lot to be desired. Still not the right one. Okay, let's highlight it. And where it's highlighted, just like in Windows, right click, copy. Now it should work. Paste as plain text. There we go. All right. Now when I run this and do my ls minus LTR, I see at 12:15 hello.f. So now let's cat that file. Guess what, folks? There's your assembler. Now, do you suppose, since this is a text file, I could change it from hello world to hello worlds or something like that? Before we do that, let's figure out one, let's make it work, okay? Let's go with what's known before we add variables. Like my troubleshooting experience with this thing, it was not about adding stuff. It was about subtracting stuff, okay? That usually helps more than adding stuff. Now notice what it says down here. This is telling me that when it was created into assembler, we're using the GCC stack, okay? There are other assemblers. There is YASM and NASM and ASM. This one is referred to assembler. And sometimes in print, you see it referred to as GAS, as in the GNU assembler. When I compile using C, C++, D, Go, any other programming language that GCC supports, the output is in this AS format that is specific to the hardware that it's compiled on. Okay. So now that's what it looks like. Now, wouldn't you love to start with this as your first programming language? What does it mean? Oh, we'll get to that. Okay. All right. Little by little, remember your for loop. Your homework is to write a for loop that prints 1 to 10 in C. Okay. Google it. I don't care, but memorize it. Okay. Because we'll use it in class next time we meet. And then we're going to see how this kind of stuff works. Okay. We're going to take a very different approach to learning programming. We're going to kind of take an experiential, let's break it. Oh, darn, that didn't work. And, oh, that did work. What'd I do? Approach. Okay. A trial and error type approach to poking around on where some of this stuff works. Why? Because you'll learn it better. You're not going to remember Boolean algebra. You're not going to remember the gates and stuff, but you're going to remember that, hey, I saw assembler once and I changed the string and I made it work. Well, what were those steps? I don't remember. But I can memorize, I can tell you what the for loop in C is. Okay. All right. The next thing we need to do is turn this into object code. And if we cat our hello C here and look at what we do. So we just did this. So now we want to take GCC, which is this S format, which is the GNU assembler, and turn it into object code. And we're going to call it hi. Okay, we can call it whatever we want, but that's what we're going to do. Okay, so I'm going to type it in GCC hello .s-o hi, and to run it, I need to prefix my executable with // Long discussion goes here. Later. Right now, just do it. Yes, there is two different ways to go to assembler. This is taking it to actual outputable .executable code. Most of the time, when you're writing assembler or working with assembler, you have a blob of code that you turn into object, but it's not executable. And then you have another blob of code. You got another blob of code. And then you put them together with a linker that takes all these blobs and turns them into one executable. Okay, that's called the linker. And in Linux, it's called LD. Okay, we will get to that. Okay, in time. Okay, little pieces at a time. Open the. Oh, you want to actually look at the hi? Is that what you're talking about? Oh, I just had that up there. Hello.s. Yeah, that one. Yeah, that's what it looks like. Okay. You can. You can. You just do. So yeah, you can. I was just using that flag of the uppercase S to show you what it's doing. Okay. All right. So now if we do an LS LTR, I want to show you something here. How many bytes different is between hi and bye? They're identical, aren't they? As far as the number of bytes. This is compiled by way of AS or .s file, right? This is the C compiled straight to object, no intermediary. That's pretty nice. Now, look how big that is. Now, your smallest hello world in Rust, same with Go. Your smallest hello world in Go, it's huge because it has all these libraries built into it. It will work on any computer that is Linux that's 64-bit. Okay. Yeah. Yeah, the cross compiling from Linux to Windows is fraught with error. I don't recommend it. But if you're going to cross compile to another, like a Raspberry Pi or some other, then it works. I agree. I agree. Cross compiling to a different architecture. Now, what I'm going to show you are $35 Raspberry Pi. And I've got 2.5 minutes to do this. So basically, I have done the same thing. Okay. I've already done it. So let's just take a look at what I've got. And cat hello.s. And notice what it says. Can you tell by looking at this if I'm on 64-bit or 32-bit? Not yet. You will. Okay. And so what we have here is the same thing, but notice this architecture right there. Can I take my Hi from the Raspberry Pi and put it on the Jupyter box? Emulator, yeah. I cannot take raw object code onto a different chipset. Our book, ZY Books, is all about MIPS, which is yet another piece of architecture. I happen to have a Raspberry and I can show you ARM. I would love to get into RISC-V. That was my original intent, that we'd be doing some of this stuff on RISC-V so I could show you real cool stuff that's happening in that space where there's just a ton of cool stuff happening in that arena, okay? But the tool chain and I don't have the hardware. Can we cross compile on a Raspberry Pi and actually make object code for a RISC-V chip? Yes, I got it working, but I don't have a RISC-V chip to run it on. Okay, anybody got one laying around? I got it all working, emulated, but I'm going, boy, if I have to teach this to you guys, I'm going to spend all my time teaching you about the emulator and not how to do that. So that's why we're doing this, okay? So same exact steps that we just did, okay? Yeah. Oh, which one? No. Object code, the .s is the assembler code. This is the C source code. This is the assembler. This is the object. And the way you find out in the world of Linux is you just type in the word file and give them to me here. So it says hello.c is C source. Hello.s is assembler source. Hi is F. And it tells you, oh, look, executable ARM. 32 or 64, folks. So I have a 64-bit, 8 GB Raspberry Pi. Okay. And we are done for the day. So hopefully you found that interesting. We're going to do it all again with the code you go look up and memorize. Feel free to put it in before class next time we meet, Monday. Okay. All right. And don't worry if this gets really kind of, because learning how to do this gets a little out there. That's why we're going to spend a lot of time there. Oh, great. Thank you. Hmm? Mhm. Thanks. Sure.
And a lot of them, like I'm missing a lot of information from sharing the conversations we'd be having in class. Is there like something?
Don't worry about it. I am teaching at a very practical, real world level. Don't take it personally that you don't feel like you're getting it. Okay. I am teaching at a very high level. Want me to slow down? Slow down. Just tell me. Now, the reason I do it this way is because I like to see my students succeed. We had a former student, and he's like a VPI in software engineering at Twitter. He makes $500,000 a year. He did a guest lecture for me. He did. He lives in the area. And I happened to meet him somewhere, and I think you do it. Like, yeah, sure. And he came and gave a guest lecture. And he said, I didn't program too much in JC.
That's all I know.
Yeah, well, that's fine. That's fine. You have a base. It's a starting point. Oh, yeah, that's a hot, hot, hot ticket. You don't need no networking. The TCP/IP stack, and Wireshark. Yeah, networking 240. Yeah, that's a step in the right direction.
Because my cousin, he didn't go to school for it. He went to like a program called Gear Up, and they did like on hand internship.
Oh, yeah. That's a great way to learn this stuff. But you have to have a base. You kind of have to know how this stuff works. Like if I say, describe to me how the network works when you click on a browser and the word hi goes from you to them. What's going on?
I don't know much yet.
That's networking. That's how you learn that stuff. So the pieces that you're missing are fillable. Don't feel bad. Now, I teach at a different level than a lot of instructors because I come from industry and I know what it takes. Like, for example, let me just stop this for a second. And okay, exit, quit Zoom. Let me turn off all the Zoom stuff. Math? Yeah, you won't need it in industry. You won't. You'll need stats. You'll need stats.
I took that.
Yeah, yeah, stats is what I use a ton of because I did a lot of financial reporting stuff. But stats you use a lot of. The calc stuff you'll use if you want to get into AI and you want to get into machine learning and graph theory and some of the things that are way out there. But don't feel like it's okay to feel overwhelmed in this business. It really is because let's see. All right. Here we go. Hold on a second. Let me just close this down because it's still recording.